In this problem, we observe two variables. There are two observed variables, x and y. When we want the mean of x, sigma 1 square is the mean of x, V2 is the mean of y, sigma 2 square is the mean of y. And then we have consider two random samples, two independent random sample. The first sample taken from the proportion x is x1, x2, to xn. Mấy cậu phải chui lên xuống dưới đấy không học ấy thì tốt nhất đi về lên, ngồi dưới thì không chịu học, cứ vào Facebook xong rồi vào TikTok rồi đi đọc internet thì các loại học không chịu học thì tốt nhất là phải phòng để cho mấy bạn ngồi trên thì các bạn đi học, ngồi dưới mất trật tự. Em ngồi cạnh cái cậu đấy thầy học mấy lần bạn ấy thầy nhớ cái việc này cứ nét cho thầy đấy, đang cầm bút đúng không? Tên em là gì? Hả? Gì? Khôi Nguyên à? Cho bạn cứ tưởng cái đùa ngồi đấy nói chuyện. Còn ai thích nói chuyện thì thầy xóa mất điểm thầy. Nó thực ra đúng không? Hay là vào 9:20 rồi, bây giờ 9:43 rồi, đúng không? Thì có một cái điểm danh rất đông. Thầy nó rất là thực ra cộng thêm cái cộng nó trật tự mỗi lần thế là mình xử lý. Còn là nó trật tự nữa. Các bạn lớp 9 đến lớp 10 nhá. Em lớp 9 đến lớp 10 em ơi. Thì tìm nó nhanh. 9 à? Nguyên đúng không? Và dù sau khi học thì ABC nhiều lớp ABC khác nhau tìm rất là thời gian. Nguyễn Khôi Nguyên. Okay. We consider two independent random sample x1 and 2 xn. The second random sample y1, y2, yn taken from the proportion 1. And we test on v1 minus v2. And in that we consider it's not the non-hypothesis. V1 minus V2 is a delta naught, and the difference under S naught is a delta naught. Against S1, V1 minus V2 greater than delta naught is a Weisel test, smaller than or equal from. What is the original statistic for this test? We use the following sampling distribution. With the following sampling distribution, the statistic Z, in fact, we use the sampling distribution of x bar minus y bar. Right? For population x and y, the difference between two random sample mean x bar minus y bar is the normal or follow normal or approximately follow normal. What the mean? Mean x bar minus y bar is normal u2 and balance sigma square over n plus sigma 2 square over n. The balance of x bar minus y bar is the balance of x bar plus balance of y bar. Balance of x bar is x sigma 1 square over n. Balance of y bar is sigma 2 square over n. Okay. Now we standardize this normal distribution. You take the variable x bar minus y bar minus this mean. This mean is minus b1 minus b2 divided by square root of standard deviation. Standard deviation is square root of sigma 1 square over n plus sigma 2 square over n for our standard normal distribution. Okay, so this sampling distribution is true if and only if what? When x and y are normal. If x and y are not normal, the sample size must be large, greater than 30. Okay, if one of these two requirements satisfied. Okay, so when we test on B1 must be 2, in fact, in total there are 30 cases. But we only study how many? 3 cases. What are they? What's the case 1? The two variants are yes, and of course, to use this sampling distribution, we must suppose that one of these two requirements satisfied. If x and y are normal or the sample size are large, greater than 50. Okay, so what that statistic? If I do the test statistic with this sampling distribution under S0, it means that S0 is true. When S0 is true, we want to do delta naught. And remember, we usually consider in our exercise, we only consider delta naught is 0. Usually consider delta naught is 0. Okay, Z naught equals x bar minus y bar minus delta naught divided by square root of sigma 1 square over n plus sigma 2 square over n follow or approximately follow standard normal distribution under S naught or when S naught is true. So we have W alpha in fact identical with rule. Rule 1, 2, 3, 7, 8, 9, and two cases for test on V. And when we test on P, we also use the standard normal distribution. So we have the rule 10, 11, and 12. And this rule is the rule number 13. 14 and 15. Continue the second case. I can open the formula of here part. Yeah. The first case when x and y are yeah. This is not the alpha. The second case. case, when sigma 1, sigma 2 square are no. And what? We consider this requirement and M are large. Okay, so what happens? What test statistic? The test statistic is when sigma when the t statistic t naught equal x bar minus y bar minus delta naught divided by now sigma 1 and sigma 2 square we replace sigma 1 and sigma 2 by this point activate by s1 square and by s2 square. And the equation is also n01. When it's not, it's 2. So the reason is factor identical with the first case. So we have a row number 16, 17, and 18. Okay. Because we have real until 1. And then what the third case? Okay, of course, sigma 1 and sigma 2 are the two variables. And then x and y are normal. With what? With equal value, sigma 1 square equal 2 square. Okay. So what the statistic? T naught is x bar minus y bar minus delta naught divided by square root of what? Sigma 1 square, sigma 2 square are also, but they are the same, they are equal. So we replace sigma 1 square, sigma 2 square by the same sample values. Divided by s square. S square is a weighted average of n1 square and n2 square. S square over n plus s square over m. And follow the Steven distribution when it's not equal or it's true. What is the degree of freedom of the Steven distribution? It's n minus 1 plus m minus 1. It's n plus m minus 2 because degree of freedom of s1 is n minus 1. Degree of freedom of s2 is m minus 2. And what is the s square? S square is the average, the weighted average, the weight is n minus 1 and n minus 1. So n minus 1, s1 square plus n minus 1, s2 square divided by n minus 1 plus n minus 1, so n plus n minus 2. Okay. So W alpha will Steven value. So from df alpha to plus infinity, if S1 is a right test, mu1 minus mu2 greater than delta naught, and smaller than or equal from similarly, from minus infinity to minus df alpha for future test. So the number of rows is the row 19, 20, and 21, right? Okay, now we come back to the following example. We apply one of these three cases to answer the following example. In this example, we want to compare the main mass is score between students between two classes. High school math teacher claims that student in her class will score higher on the math portion of ACT than student in her college math class. So we want to compare the math ACT score between two classes, her class and her college class. We take two random samples. The first sample consider 49 students in her class, and we observe the mean ACT math score of 49 students in her class is 32.1, and the sample standard deviation is 4.8. The mean ACT math score for 44 college students is 19.8, and the sample standard deviation is 5.4. Research question up by 10%, can the teacher claim be supported? In fact, the teacher claim that her students are more intelligent than good college students because from the sample, the mean ACT score of students in her class is 22.1 is greater than the mean ACT score of 44 students in her college class is 19.8. So she states the research question, the research hypothesis, whether the student in her class will score higher or math ACT score than student in her college class. So in this problem we compare what? Two population mean. To compare the mean ACT, the mean math ACT score between two classes. So here's an example of a problem of testing on V1 versus V2. We compare two population mean. Okay, to perform a test, you follow how many? 7 steps. What's the first step? First step. Okay, we are correct very quickly this example. The first step we define two object variable. What are two object variable? Let x and y be what? Is math ACT score of student in her and in her class and in her college class. Let's say history. And the second step. What second step? We state the assumption of the problem. What the assumption of the problem? Which way we are, the first, the second, or the third? We know sigma 1 and sigma 2? Yes or no? No. Why? In fact, 4.8 and 5.4 is not the population standard deviation. It's a sample standard deviation. So it's S1 and S2. It's not sigma 1 and sigma 2. So in this example, sigma 1 and sigma 2 are because we are the second or the third case. The population are normal. No, you are not given population are normal, right? But the sample size n is a 49 and is a 44 are large enough. So you are given the second case, right? You write the assumption of the second case. We have the when and sigma 1 square is a Vh, sigma 2 square equal Vy n n is 49, m is 44. That's enough. Okay. The second step, you take the assumption. We have the second case, so the assumption of the second case, the phase and are unknown, and the sample size large enough. What's the third step? We said it's not NS1. It's not NS1, say about mu1 and mu2, the difference between mu1 and mu2. So first step, we must define two parameters mu1 and mu2. Yeah, we don't have the parameter mu1 and mu2, so we must define. What is the mu1? mu1 is the mean of x, so it's the mean score, mean mark density score of student in her class. mu2 is the mean mark density score of student in her college class. mu1 is the mu x, mu2 is the mu y, and we test what is S0 and what is S1? We test on mu1 minus mu2. S0 minus mu2 equals what delta naught? Delta naught is 0. Yeah. Delta naught is 0. But we want to test whether mu1 greater than or smaller than mu2. Greater than, because we want to test whether her students are more intelligent than her college students. So we want greater than mu2. We want minus mu2 greater than mu2. Alpha equal very 10%. Significance. Okay. What is the next step? What is the first step? Before we show the test statistic, what is the test statistic for this guy? Is the t statistic equal x bar minus y bar minus delta naught divided by delta naught is 0. Divided by square root of s1 square over n plus s2 square over n follow and 0 1 if s naught is 2. And then for the given sample, we have the observed value of T of is x small bar minus y small bar minus 0 divided by s1 small over n plus s2 small over n. X bar is 22.1, y bar is 19.8, s1 square is 4.8 square over 49. Plus 5.4 squared over 44. Okay. And we compute what is this value? This value is 2.60. 2.60. Okay. And then, what's the fifth step? We find the reason needed. What reaction is it? When we look at S1. S1 is the right content, so it's interval from orbit the point to infinity. That's right content. And then we look at where the distribution of that statistic S01, so from the alpha. 0.1 to plus infinity, 0.1 is 1.28, right? So what's the conclusion? Step 6. We have a T of 2.16 binomial does not belong to the alpha. Binomial. Then there is enough evidence to reject it not alpha is a 1%, 10%. So what the conclusion? Second step, make a conclusion. There is enough evidence to conclude that her students are more intelligent than the college student. It means that her student score higher research. Student will score higher on master ICT than college student. Score higher on master ICT exam than college student. By 10%. Okay. There is enough evidence to support the teacher claim. The teacher claim that her students score better on the ACT than the college student. This example. Now we look at the solution of this example. Remember when you perform a test, you follow a 7 step. We call the procedure of testing. The first step, you define the observed variable. We define 2 observed variables, x and y. And the second step, you state the assumption of the problem. The third step, you state S0 and S1. The fourth step, you choose the test statistic and you compute the observed value. The fifth step, you find the reason region. The sixth step, you make a decision. And the last step, you make a conclusion. You answer the question. Okay? So there's the test in machine. And now we have break 10 minutes and we consider some additional questions. About the test, to understand the problem of the testing. Okay. Question 1. We have